Purposeful Nudge introduces the Bottleneck Migration, the impact of AI and hardware on organizations and future planning.
Right now, corporate executives generally view artificial intelligence as a software expense. They manage it through seat-based licenses and rely on distant cloud hyperscalers to do the heavy lifting. But the technology has moved past simple prompt-based chatbots. We are entering the phase of Agentic AI, continuous background processes that index local files, monitor user workflows, and take autonomous action without waiting for a prompt. Running these always-on agents through the cloud creates immediate operational failures. High network latency makes real-time assistance impossible, while runaway API token costs and data privacy risks make the model financially and legally unsustainable. To make Agentic AI viable, the compute workload must migrate out of the cloud and directly onto the physical device on the employee's desk. Moving AI to the local device requires a specific high-performance hardware architecture to function. Most existing Office laptops simply lack the physical components to run these models. Microsoft's Copilot Plus standard established a new hardware floor, 16 gigabytes of RAM and a dedicated NPU, or neural processing unit, capable of at least 40 trillion operations per second. Localizing the compute hasn't removed the bottleneck. It has simply moved the pressure point from the cloud server directly onto the employee's workstation. Older laptops manufactured before mid-2024 are physically incapable of handling the sustained, continuous computation required by local AI. Forcing these models onto legacy hardware leads to a rapid internal breakdown of the machine. The first failure occurs at the memory pathways. As the processor struggles to fetch gigabytes of model weights, it triggers intense joule heating, forcing the system to throttle performance to prevent a total shutdown. Because these AI agents run continuously, the hardware never enters a low-power sleep state. This constant baseline draw generates sustained heat adjacent to the battery compartment, which chemically degrades lithium-ion cells and leads to physical battery swelling. Rapid thermal cycling, the constant heating and cooling of the processor, eventually fatigues the microscopic solder joints on the motherboard. Meanwhile, the cooling fans are pinned at maximum speed until their bearings fail, long before the laptop reaches its expected lifespan. Treating AI as mere software is currently destroying the enterprise hardware fleet from the inside out. The natural response to melting hardware is an immediate fleet-wide upgrade to NPU-equipped machines. However, global economic constraints make this impossible for most organizations. Global foundries like TSMC are already approaching full utilization through 2027 to supply data centers, choking the supply of the silicon needed for local devices. Memory manufacturers like Micron have heavily pivoted their capacity toward high-margin server chips. This has caused a massive supply and demand imbalance for the DRAM used in laptops, where spot prices have spiked by 50%. Despite these costs, the shift is unavoidable. Industry forecasts show AI PC adoption will cross the 50% mark by 2026, as companies feel forced to upgrade to stay competitive. The traditional 3-year hardware refresh cycle is over. Organizations cannot wait years for their legacy fleets to fail, but the current supply chain makes a total replacement cost prohibitive. Relying on arbitrary, calendar-driven hardware replacement will destroy a company's AI return on investment. To manage this transition, field services departments must pivot toward a lifecycle model driven by real-time hardware intelligence. IT teams are now using telemetry to track physical distress signals in the fleet, measuring real-time NPU utilization, memory swap rates, and thermal spikes to generate a device performance score. This data triggers a condition-based upgrade. A machine is replaced only when the telemetry proves the hardware is actively choking the employee's productivity. The physical condition of the machine, rather than a date on a calendar, now dictates the hardware budget. To survive the inflated costs of AI-capable PCs, organizations are implementing a financial framework called the value cascade. In this model, high-spec machines are first deployed to power users like developers. After 2 years, rather than being discarded, those systems are refurbished and cascaded down to standard office workers with lighter compute demands. This circular methodology recaptures capital and extends the utility of expensive hardware while simultaneously reducing the organization's electronic waste. Mastering enterprise AI deployment is now a hardware mandate. Success depends on moving past software licensing and learning to listen to the physical telemetry of the edge fleet.
For more insights, subscribe to Purposeful Nudge and start rewiring your field services organization today.